So in this video, I'm going to go over obtaining a region of interest from a functional map. So first I'm going to go into the MRICron workshop materials folder that hopefully you've downloaded. See the link in the description if you have not. And we're going to use the MRICron Windows version. And so just left click to open it. First, what we want to do is open our statistical map. Within the MRICron Workshop Materials folder, I have an examples folder, and what we'll do is go in MRICron, go to File, Open, and we'll go into the examples folder and select ZMap and click Open. First, you want to set the auto contrast, so just left click on that, and so now the map should show up on your GUI. And so I'm just left clicking at the top of the superior portion of the brain and scrolling down. You notice these bright regions are where there are high Z values and the dark regions where there are very low Z values. So in order to identify a functional cluster that's relevant for us, we can set the minimum value to whatever threshold that we want. And let's say that we want to use a threshold of Z of 2.3, because that's equivalent to a p-value of 0.01. We can set the maximum to anything above 2.3. So now we see that all the voxels that are less than 2.3 are blocked from view. And so in this view, it's actually hard to tell where you are in the brain. So as we're proceeding, we can open another MRICron window. So I'm going to right click on this icon down at the bottom and open another MRICron window and make sure that you're yoked. So go to View and check Yoke in both windows. And so now when you click in one window, it will jump to the same coordinate in the other window. If you want a more informative brain map with labels of where you are, you can open, let's open the AAL Atlas. So let's open a standard anatomical atlas, the automatic anatomical labeling atlas that comes with MRICron. And so I'm going to go back and I'm going to focus on this cluster here on the left side, right? And so this is in the left inferior temporal gyrus, okay? And so let's say I want to just obtain a volume that only includes this particular cluster. I can use the 3D bubble tool, select it, and I will change the difference from origin to the maximum, which is 255, and the difference from edge to 255. And critically, I'm going to set the zero intensity constrains the edge, and check that. So now we're only including this cluster at a threshold of 2.3 Z values, or 2.3 standard deviations. Okay? And the radius just needs to be larger than the actual extent of the cluster. You can see my lesion drawing video for details about what these different parameters mean, but basically the difference from the origin and difference from the edge are with respect to the intensity values at whatever voxel that you're actually located in. And so the intensity values are listed up here in the top left. So these are the Z values for this particular map. Okay? When you have your cluster, you can click Apply, and then you can go to Draw, Save VOI. And so I realized that it's a bit confusing. Conventionally in neuroimaging literature, people use the term ROI for region of interest. In MRICron, they use the term VOI for volume of interest, which is just essentially the same thing. And so I use these terms interchangeably. For MRICron, it refers to a file format that's unique to MRICron. So you can go Save VOI. And so the volume of interest format is by default. I like to save files in NIfTI format because it's a general file format used by many different neuroimaging software packages. So you can select that, and I will just save this as, call it cluster, okay, and click Save. Okay, so now I've saved a functional region of interest based on a statistical threshold from this map. And now if I go to File, Open Templates, I'll use the CH2 Better Brain. This is the preferred brain that I like to use for overlaying statistical maps or regions of interests. And now I can go to Overlay Add, and I'm going to select the cluster, again in the Examples folder, and I will hit the Auto Contrast button, right? And so now we can see our cluster down here. And this is a binary file where it's just ones and zeros, so ones where you see the red and zeros everywhere else. If I want to see a rendered view of this, I can go to Window, Render, and you'll see the cluster down here. This is just a surface projection of whatever you see in the slice view in the main MRICon GUI. So another simple thing you could do is determine the volume of this cluster. You can go to Draw, Descriptive, and here you can see at the top row it gives the number of voxels here and the volume in cubic centimeters, so 2.3. These don't necessarily match because the actual resolution of the underlying image, the CH2 Better Brain, is less than millimeter resolution. Okay, so I'm going to make another cluster from our functional ZMAP. So go to File, Open, select ZMAP, left click on the Auto Contrast button, and I'm going to set the minimum to 2.3 Z values again, and the maximum I'm just going to set to 2.3 to make things easier to view. So I already have this anatomical atlas open, the AAL atlas, and so that will help us determine where we are in the brain. And so I'm going to select this left inferior parietal lobule cluster, and I'm going to create a region as I did before using 3D bubble tool. Select it. Still has the maximum values for these difference parameters set, and the radius is larger than the extent of this cluster. And so I'm going to click Apply, and then Draw, Save VOI, and I'm going to save it as a Nifty file format, and I'm just going to call this cluster 2 and save it within the examples folder. So the next thing you can do is, let's say you want to combine these two regions of interest together into one single file. So what we can do is go to Draw, go to Statistics, and say Create Overlap Images. And what we have to do is select the files that we want to combine. So I'm going to change the format down here in the lower right to Neuroimaging. I'm going to select these two clusters. So left click and then Control left click to get both of the file names selected. Click Open. And I'm going to change it to Nifty format. And I'm going to change the name to Cluster Combo and save it within the Examples folder. Click Save. Okay, so now these two clusters I made, one in the parietal lobe and one in the inferior temporal gyrus, are now combined into one file. And of course, another way you could have done that is just drawn these regions within the statistical map at the same time. But I'm demonstrating ways you can use the MRICon to get ROIs, split them, and combine them together again. The next thing you might want to do is assign different numbers to these clusters. So you can look up here in the upper left. You see that the value is 1 wherever I select wherever we are in for this region. So we can go to, I'm going to close this overlay, close overlays. Okay. So now we can see, the functional map that we were working with before. And what we can do is I'm going to close this VOI, close VOI, and I'm going to open the combination map that we were just working with. So I'm going to go to Draw, Open VOI, and I'm going to change the format to Nifty, well, in this case Neuroimaging, and select the cluster combo file, click open, and now you can see these clusters pop up again. And so I want to change the value, so I want this cluster up here in the inferior parietal lobule, I want that to be 3, and I want this inferior temporal gyrus cluster, I want that to be 2. First, let's get rid of every other voxel intensity value in the statistical map. So go to Draw, Mask Image with VOI, Preserve Regions within VOI, so that gets rid of everything else. So no matter what intensity value threshold you set, everything else is gone from this image. And what I can do is draw Close VOI. All right, so now I only have the values for these two clusters in this map. So first I'm going to change in the inferior temporal gyrus map, I'm going to change this to 2. So I'm going to use the 3D bubble tool. I use the same parameters as before, click Apply, and then go to Draw, Mask Image with VOI, and change regions with VOI to custom intensity, and I'm going to change it to 2. Click OK. So now the intensity value is 2 here. And I'm going to go up to the inferior parietal lobule. And so first let me close the VOI, and we don't need to save it. We can go to the inferior parietal lobule cluster, click Apply. So click on the 3D bubble, and the same parameters still work that we had used previously. Click Apply. And now I'm going to go to Draw, Mask Image with VOI, and change regions with VOI to custom intensity. And now let me set this to 3, and click OK. So now the values within this cluster are set to 3. So now we have 2 and 3. Okay. I'm going to close the VOI. Don't need to save it. And so now we need to save this underlying image. So go to File, Save Nifty, and we're going to save it as a Nifty file format. And we're going to save it as the cluster combo, but I'm going to put 2_3 to indicate the intensity values. So let's save it. So if I go to File, Open Templates, and open the CH2 Better Brain, and overlay, add the cluster combo 2_3, we can set the auto contrast button. So the values here in the inferior temporal gyrus is 2. You can see it up in the upper left, and in the inferior parietal lobe it's set to 3. If you want to see this more clearly, you can change the color scale to say spectrum instead of green, and so now you have 2 different colors associated with these 2 different clusters. You can also change the minimum and maximum if you want to have different colors associated with the values from the spectrum color scale. And we can change the minimum to 2 and the maximum to 3. This is because by default selecting the cluster combo 2, 3. If you accidentally select the background instead, these are the intensity values of the underlying image for the minimum maximum. So if you start changing that, then you're going to change the underlying image color scale. We prefer to use the grayscale for the underlying image. And lastly, one thing you might want to do is view these clusters in a rendered view. So go to Window, Render, and here you can see the inferior temporal gyrus and inferior parietal lobule cluster. And you might, if for some reason you don't see this magenta cluster down here, you can go to and check the settings in the overlay up at the top and set this to 0%. If it's set all the way to the maximum, you won't be able to view it. I'm not going to go in super detail about these different parameters, but you can play around with them.